Hi all, welcome to Learn Easy channel. Today's topic is Lewis theory or Lewis dot structure representation. Let us see some details about the Lewis theory. The famous American scientist G.N. Lewis introduced symbols for Lewis dot structure and they are called as Lewis symbols. Another scientist, Kozel and Lewis, they together postulated Kozel-Lewis theory of chemical bond formation. Okay, now we see the steps to draw the Lewis dot structure. There are three steps to draw the Lewis dot structure. The first one is to calculate the valence electron. When we are calculating we all know that the outermost number of electrons in the outermost shell is the valence electron. When we are calculating the valence electron, if there is an anion, we have to add one electron for one charge. If there is a cation, we have to remove one electron for one charge. This we see in detail when we are doing the examples. Okay. Next step is to find the central atom. To find the central atom, we have to see the least electronegative element or the least number of atoms or atomic number, which atom has the highest atomic number. Depends on that atom will be the central atom. Okay, when we do with examples, it is easier to understand. Okay, next we go to the formal charge. For formal charge, there is one formula to find the formal charge. That is the number of valence electron minus number of non-bonding electron minus bonding electrons divided by 2 will give the total formal charge of the given atom. Okay, now we'll see different examples to draw the Lewis dot structure. Next we see some examples for calculating the valence electrons. First I have taken here H2 molecule. There are 2 hydrogen atoms in the H2 molecule. So 2 into valence electron of hydrogen is 1. So 2 into 1 is 2. So total valence electron is 2. Next we go for CH4. For CH4 there is 1 carbon atom and 4 hydrogen atoms. So valence electron for carbon is 4. So 1 into 4 plus we have 4 hydrogen atoms. So 4 into valence electron of hydrogen is 1. So 4 into 1. So totally 4 plus 4 will give 8. So total number of valence electron is 8 for CH4. Next we go for NO3 minus ion. For NO3 minus we have an anion minus ion. So depends on that we have to calculate the total number of valence electron. So for nitrogen we have valence electron is 5. So 5 plus we have 3 oxygen atoms. So 3 into valence electron of oxygen is 6. 3 into 6 plus we have plus 1. This plus 1 is for this anion. We have minus anion here. So for minus 1 we have adding 1 electron. So 5 plus 18 plus 1. So totally we get 24 electrons for NO3 minus ion. Next we go for NH4 plus. For NH4 plus, valence electron for nitrogen is 5 plus we have 4 hydrogen atoms. So 4 into 1. And for plus 1 cation we are removing 1 electron. So for plus we have to remove 1 electron minus 1. So 5 plus 4 minus 1, totally 8 electrons for NH4 plus. Next we see how to find the central atom. I have taken an example of BF3 here. So for BF3 we can draw a structure like this and also like this. Like boron in the center and fluorine in the center. So to find the central atom, we have to see there are many factors to find the central atom. First thing is we can see the least number of atoms. So boron has the least number of atoms, so we can write boron in the center, or we can see the least electronegative element. Here boron is the least electronegative element, so this structure is the correct structure and this is not a correct structure. So boron will come in the center. Central atom will be the boron. So we can find the central atom by the least electronegative element or the least number of atoms or the atom which has the highest atomic number. Okay, so in this one BF3, this structure is the correct one and this is the wrong structure. Okay, next we see some representation of elements using Lewis dot theory. Here I have taken some examples. For lithium, you know, for lithium the electronic configuration is 2, 1. So we can represent lithium as, we have one valence electron. So we can represent it like this by a single dot. Okay. For carbon the electronic configuration is 2, 4. So there are 4 valence electrons. So we can represent carbon like this by drawing a 4 dot structure, 4 dots for 4 valence electron. We have to represent this valence electron in the form of dot. Okay. Next we see for nitrogen. So nitrogen, the electronic configuration is 2, 5. So valence electron is 5. So we can represent nitrogen like this, 1, 2, 3, 4 and 5. So the 5 valence electron we have to represent it using dots. Okay. Next we see example of fluorine. Fluorine, the electronic configuration is 2, 1s2, 2, 7. 1s2, 2s2, 2p5. So 2, 7. The number of valence electron is 7. So we can represent fluorine like this, 7 valence electron, 1, 2, 3, 4, 5, 6 and 7. So totally 7 valence electrons. So we have to draw 7 dots. Okay. Next we see for sodium. The electronic configuration of sodium is 2, 8, 1. So number of valence electron is 1. So we can represent sodium like this. Now we see the dot structure representation of some molecules. First example here I have taken is H2. H forms a single bond with another hydrogen atom. So total valence electron for hydrogen is 2 hydrogen atoms. So 2 into valence electron is 1. So 2. Bond pair of electron is 2. Bond pair of electron is nothing but the bond between the two atoms. There is a single bond here. So single bond we need 2 electrons for bond pairing. Same thing for double bond, we need 4 electrons, and for triple bond we need 6 electrons. So bond pair of electrons in H2 is 2 electrons, and we need to find the lone pair of electrons. So for finding the lone pair of electron, there is a formula: total valence electron minus the bond pair electrons will give the lone pair of electrons. So total valence electron here is 2 minus bond pair of electron is 2. So there is no lone pair of electrons here. So now we see how to draw the dot structure for H2. H2, there is one valence electron for each hydrogen atom. They both will share. So each will attain the duplet rule. This hydrogen will attain the duplet rule and this hydrogen also will attain the duplet rule. So hydrogen forms two hydrogen atom will form a single bond. Okay. So each valence electron we need to draw a dot so that it should attain the duplet in this case. Okay. Next we'll go for O2 molecule. O2, we know that O2 will form a O double bond O. Double bond will be formed here. So total valence electron for oxygen is, there is 2 oxygen atoms, so 2 into valence electron for oxygen is 6, so 2 into 6 times is 12. There are totally 12 valence electron for oxygen. Bond pair of electron here is, there is a double bond here, so 4 electrons. Lone pair of electrons here is 12, that is total valence electron is 12 minus 4. So totally 8 electrons, 8 electrons will be the lone pair of electrons. So we now see the dot structure for O2. So O should have totally 8 lone pair of electrons and total valence electron is 12. So 1, 2, 3, 4, 5, 6. Another oxygen 1, 2, 3, 4, 5, 6. So these two will form a double bond. So we count the lone pair of electrons. 1, 2, 3, 4, 5, 6, 7, 8. So there is 8 lone pair of electrons in O2, and this oxygen will attain a octet rule, and this oxygen also will attain an octet rule. Okay, this is the dot structure representation of O2. Now we see for nitrogen, and N2 will form a triple bond with another nitrogen atom. So total number of valence electron for N2 is 2 into 5, that is 10 and 10 valence electrons, and bond pair of electron is 6 electrons. Since we have three bonds here, triple bond is here, so 6 electrons. And to find the lone pair, we have to subtract number of valence electron 10 minus bond pair of electron is 6, so totally 4 lone pair of electrons should be there. Okay, we'll see. Now we see how to draw the structure, dot structure for N2. For nitrogen, we need 5 valence electron, 1, 2, 3, 4, 5, and for this nitrogen 1, 2, 3, 4, 5. So totally 1, 2, 3, 4, 5, 6, 7, 8 octet rule is attained for this nitrogen, and octet rule is attained for this nitrogen. And now we count the number of lone pair. 1, 2, 3, 4. So 4 lone pairs. 4 lone pair of electrons is there in N2. Okay, now we go for the next example, NF3. In NF3, the total valence electron is 5 plus 7 into 3. 5 is valence electron for nitrogen, and for fluorine 3 atoms are there. So 3 into valence electron for fluorine is 7. So 5 plus 7 into 3 is 21. So totally 26 valence electrons. And bond pair here is all are single bonds. So totally 6 electrons are there for 6 electrons are used for bond pairing, and lone pair of electrons is equal to 26. That is, total valence electron is 26 minus bond pair is 6. So totally 20 electrons should be there for lone pair. Should be therefore a lone pair for NF3. Now we go for the structure of NF3. First we draw nitrogen, fluorine. For nitrogen 1, 2, 3, 4 and 5, and for fluorine 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6 and 7, and for this fluorine 1, 2, 3, 4, 5, 6 and 7. So for this fluorine, octet rule is attained 1, 2, 3, 4, 5, 6, 7 and 8 like this, and here 7 and 8 like this, and for this fluorine also like this. For nitrogen 1, 2, 3, 4, 5, 6, 7 and 8 octet rule is attained for nitrogen also. Okay, so these two electrons will form a single bond with fluorine. Okay, now we count the number of lone pair of electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19 and 20. So totally 20 lone pair of electrons for NF3.